The Flex4RES project analyzes flexible Nordic and Baltic energy systems. This video presents results for Sweden. Let's first have a brief overview of the scenarios applied in this study. Business as usual lets the energy system progress according to the Nordic Energy Technology Perspectives Carbon Neutral scenario and NSOE's 10-year Network Development Plan. Connect allows for additional expansion of transmission in addition to the 10-year Network Development Plan, and policy eliminates regulatory barriers in form of volumetric taxes and tariffs on electricity, exchanging them with capacity-based ones. This is intended to enable more flexible use of electricity. And finally, Combi combines the policy and connect scenarios. Looking at the key findings for Sweden, the additional investment in transmission allowed in the connect scenario results in a 36% increase in wind production and also significant deployment of solar PV. This leads to increased electricity exports from Sweden. Changing the current regulation towards capacity-based grid tariffs and taxation, power-to-heat capacity is increased significantly. This takes the share of power-to-heat to 55% of all heat generated in district heating. All scenarios show a wind and solar share of electricity supply around 50%, and a decrease in biomass and nuclear capacity. Now, let's have a look at the results in more detail. We start out in the electricity sector. As mentioned earlier, the impact of introducing transmission capacity leads to a large increase in wind and solar capacity, assuming that distribution grids have the capacity for the solar PV. The optimal is combining increased transmission capacity with regulatory changes. This leads to the largest deployment of wind and solar. Despite the large solar PV capacity, low capacity factors means relatively less generation compared to wind. A shift from solid biomass to biogas is seen in all scenarios over the years, and a phase-out of nuclear becomes apparent towards 2050. And now let's look at the heating sector. Heat generation capacity is reduced in all scenarios due to an assumed increased efficiency in operation. Installed capacity of biomass boilers increases along with power to heat with the new tax and tariff scheme in the policy scenario. Whereas the largest deployment of biomass CHP and power to heat is seen in the Combi scenario. While waste continues to make up a significant share of heat supply, power to heat displaces biomass in all scenarios. Power to heat use is most pronounced in the policy scenarios, but variations among scenarios is generally quite small. And finally, let's look at the storages. Already from 2030, we see a large deployment of especially seasonal storages, a deployment that increases over time in all scenarios. Increased transmission is followed by a larger share of short-term storages as a way to utilize the relatively larger shares of power to heat and combined heat and power. And finally, without transmission, flexibility will be provided by seasonal heat storages as seen in the business as usual and policy scenarios. You can find similar videos with country profiles and recommendations the same place you found this one. For even more details, have a look at flex4res.org.